Hey everybody, welcome back to Homework 10 video series. Got question 3 up right now. We're going to be ranking these compounds in order from lowest to highest melting point. Our game plan is that we're going to rank them from the weakest to the strongest intermolecular forces. This is kind of like question 10-2, where the stronger our intermolecular forces, the more energy, thus the higher temperature it's going to be for that substance to melt. So we're going to put our strongest intermolecular force with the highest melting point and our weakest intermolecular force with the lowest melting point. We need to first identify, though, which intermolecular forces are going to be present in these 4 compounds. So what you'll want to do for that is draw out the Lewis structure for each of them. We've drawn out the Lewis structure for CH4. If you draw out the Lewis structure for pH3 and for NH3, these are both going to be tetrahedral shapes with one lone pair of electrons around the central atom, making them both polar compounds. The pH3, however, is a polar compound that does not contain NO or F, or a hydrogen bound to those atoms. So that means that the pH3 compound only displays dipole-dipole intermolecular force as its strongest IMF because it's a polar compound, but it doesn't contain one of those F, O, or N atoms that we need to hydrogen bond. When we look at the ammonia, however, the NH3, we again have a central nitrogen surrounded by 3 hydrogens and then one lone pair of electrons in our Lewis structure. That's going to make us a polar compound. And in this compound, we have a hydrogen connected to a nitrogen, and that nitrogen has a lone pair on it. So this is a perfect example of a compound that exhibits hydrogen bonding. That's going to be a very strong intermolecular force. However, we have one other intermolecular force that is stronger. Calcium chloride is an ionic compound. It contains ion-dipole intermolecular forces. This is something that we did not discuss in the lecture videos posted in Lon Kappa. If you watch my merit lecture videos that are posted on Compass, you can understand ion-dipole forces there, or you can check out my slides on Compass. What I'll say for the purposes of this video, however, is that ion-dipole are the strongest type of intermolecular force. They're stronger than hydrogen bonding, dipole-dipole, and London dispersion force. Anytime you have an ionic compound, that compound will exhibit ion-dipole intermolecular forces. Because ion-dipole are stronger than H bonding, we're going to put calcium chloride with the highest melting point. It has the strongest intermolecular forces. Therefore, the individual particles of calcium chloride are going to require the most energy or the highest temperature if we want to get them to separate and then melt. Our weakest intermolecular force is the London dispersion force coming from CH4. So we're going to put CH4 with the lowest melting point because its physical particles are not held together very well. So we're not going to have to apply that much energy, as in we're not going to have that high of a temperature if we want to get CH4 to melt. And then we rank the other 2 accordingly. So dipole-dipole forces are stronger than LDF, but weaker than hydrogen bonding. And then hydrogen bonding forces are stronger than dipole-dipole, but they're weaker than ion-dipole. So that's how we get our ranking for this problem. And now we're all done.